Today, Emily will be discussing about the pH. Carry on, Emily.
So today's topic is pH and it has four concepts with it. The first concept I'll be covering is what is pH, and the second one is pH scale. Third is how to calculate pH value, and the fourth is Henderson's derivation. So looking on to the first concept, we will be knowing what is pH. So the pH defines as the P is power or potential and the H is proton. So moving on to the next one, here we have two different aspects. One is pH and pOH. This OH is nothing but we will be calculating it in OH minus, and the H here is we will be calculating it in H plus. These two different aspects have two different totally different formulas. The first one which we will be determining it with H plus is pH is equal to minus of log H plus, and the second one with OH minus is POH plus pH is equal to 14. The most important thing is P should be in small letter and H should be in capital. Moving on to the second topic, it is pH scale, as we have learnt in from our class 9. It varies from 0 to 4, 4 to 7, and 7 to 10, 10 to 14. So the 0 to 4 period is a strong acid and 4 to 7 is weak acid. So the acidic medium decreases on moving on from the pH scale. It is acidic strength. And the 7, this is most important thing, it is very neutral.
You can change the spelling, that is acidic, not acetic. ACIDAC. Yeah, proceed.
And 7 to 10 is weak base and 10 to 14 is strong base. So the basic medium increases on moving with the scale, and it is called alkaline strength. The basic medium is called alkaline strength. Moving on, this is off with the pH scale. Moving on to the third topic, it is very important how to calculate pH value. So we have, as I said earlier, we have two different aspects and two different formulas for it. One is pH is equal to minus of log H plus, and another one is POH plus pH is equal to 14. This formula can be used, you can just find the pH and you can use it to find the POH value, or you can find the POH and use it for pH value. So I have just given the example for this and I will just orally tell this example. So the first example is, the question is, the H plus ion concentrated is a solution that is having 0.001 m. So we should calculate what is pH. So we can use this formula. pH is equal to minus of log H plus. pH is equal to minus of log H plus, which is, they already gave the molarity. Is equal to minus log 0.01 m. So here we are going to use logarithms also. Is equal to minus log 1.0 into 10 to the power minus 3. The minus 3, we just converted this value into 10 to the power minus 3. Is equal to 3 bar by taking logarithms, 3 bar 0.000, and this minus, we are just taking this without the bar, and the minus and minus adds up to plus, and it is plus 3. The pH is plus 3. So for this, the best example is NaOH plus H2O gives Na plus OH plus H plus OH. So we have two OHs there. So we can just calculate the OH value and we can just subtract with 14 and we can just obtain the pH. This will be a good example for it. And the next important topic is Henderson's derivation. It's this is an equilibrium equation. Acetic acid gives to CH3COO minus plus H plus. So with reacting with water, this is the basic thing. We should take the weak acid and react with its acetic salt and strong base. So CH3COO Na has a bit greater alpha than CH3COOH. It gives up to CH3COO minus plus Na. These both have common anodes. Dissociate constant of weak acid Ka. Ka is equal to CH3COO minus H3O and CH3COOH.
What
So
does that square bracket represent?
concentration. So we need we need to find H3O. So we are just taking in the Ka and we are just adjusting the equations for it. So CH3O plus gives is equal to Ka
H3O plus.
H
Hydronium ion.
H3O plus hydronium ion Ka into CH3COOH by CH3COO minus. So this is the next step from here. So this is acid, right? And this is conjugate base. That's nothing but salt. So it's acid by conjugate base, and CH3O plus
Not
gives,
CH3, H3O plus only.
sorry, H3O plus gives to Ka acid by salt. As I said, conjugate base is nothing but salt. And take log on both sides. We are going to just add the logs on both sides. Log H3O plus gives log Ka plus log acid by salt. So we need to add log on these three values and reverse the signs. So what happens if we reverse the plus signs on all the sides? It becomes minus, and this is third equation. Substitute pH is equal to we know that pH formula is minus log H3O plus. So I didn't say that. You can just take H or H3O plus. So here we have that value. So we are just putting pH on this. pKa is equal to minus log Ka in equation 3. Yeah. pH is equal to pKa minus log acid by salt. pH is equal to pKa plus log. We are reciprocating this, so the minus becomes plus. This is equation number 4. For basic buffer solution, the same procedures take place, and we will have POH is equal to pKb, that is a base, plus log salt by acid. For acid, we will just take it base. So this is the old pH concept. I hope you guys understood. Thank you.
Very good.